Hello student, I'm going to continue another topic related to animation. Initially, I'll try to understand or make you understand that actually here we can see from the beginning itself, it's about what is animation and how we can create the animation. First one way is that create objects in computer and then render them as like we have discussed in the previous video also. Other methods, like suppose you can create paintings using some painting tools or other picture animation picture creation tools, and you can create one single frame, and then by creating more same type of frames you can compose them. It's like flipbook or frame based animation. These can later be either saved as a movie file or output to video. And third one is that third one method that is about making computer animation is to use transitions and other special effects like morphing to modify the existing images and video. Computer graphics are any types of images created using any kind of computer. There is a vast amount of types of images a computer can create. Also there are just as many ways of creating those images, and images created by computers can be very simple, such as lines and circles, or extremely complex, such as fractals and complicated rendered animations. So we can use computers to create those type of image frames or images to create the frames, and then we can create animations using those frames. And we can use lines and circles like simple objects. We can create in computers also. We can create complex objects like fractal images or fractal objects, and we can and in that way we can render the whole objects, created objects, using various geometrical or mathematical calculations. So if you want to create your own computer graphics, no matter how simple or complex, you have to know a few things about computers and computer graphics and how they work. And basically, the things we have discussed till now about computer or computer graphics, we have come across a various topics and information till now. So you need to apply those things anyhow to understand or to apply or to create the animations, and you need to understand how they work. So here you can see few topics or few extremely important topics that can be related to animation, like anti-aliasing or binary system, bitmap graphics, or like keyframe or modeling, morphing or wrapping or mesh or object oriented graphics. So these topics might be related with the animation. Also, there are various other like Boolean operation, contouring, coordinate systems, digitizing, dithering, phase, file dice, fractals, hierarchy, inverse kinematics. That is about physical movement, vertex and transitions. Transitions like any, it might be any transformation or transitions, surface mapping, resolution, rendering, real-time rendering, or primitives about pixels or onion skimming, like that. So there are various topics that are related to animations. So you can go through one by one, or you can understand those things by searching or by reviewing various literatures exist in the research field. So basically, if we go through one by one, suppose a few of them will be important, so I'll go through few of them. Like first one is rendering. Rendering is the process a computer uses to create an image from a data file. So most 3D graphics programs are not capable of drawing the whole scene on the run with all the colors, textures, lights and settings. Instead, the user handles a mesh which is rough representation of an object. When the user is satisfied with the mesh, then he renders the image. So here you can see this part is the mesh of the objects. So the user try to create this mesh and try to put some lights and shading and other informations, and then that user will go through the rendering process. Then only that thing will be appear like a normal object or real life objects. So here you can see rendering is a process a computer uses to create an image from a data file. So initially these things are only the data informations or data files, and that will be converted to image frame. That is the process, or that is called rendering. So most 3D graphics programs are not capable of drawing the whole scene on the run. So we cannot create the whole scene or frame on the run with all the informations that we can give. Instead, the user handles a mass with rough representation of an object. Then, or when the user is satisfied with the mass, he or she then renders the image. So we can go through rendering with various types of process, like we can create a wireframes. This is not really rendering method by definition. Most 3D graphics programs represents objects as a masses. Masses means combination of or a complete objects, or it's actually a surface. That surface will be comprised of or comprised by polygons. It might be triangle, it might be square, or it might be polygons of any number of vertices. So that whole object will be created by adding a concatenated polygons. So that wireframes is created or provides by various animation tools or animation software. So this is actually not the rendering process by definition, but most 3D graphics programs represents objects as a masses. What happens in the wireframe rendering is every section of this mass gets colored in with the average color of the texture. So this comes in useful for special effects or quick previews to take wireframe rendering one step further. So to take wireframe rendering one step further, some programs do a process called hidden line removal. It is like normal wireframing rendering, except the parts of mesh that would not be visible if the mesh was a solid or not rendered. So rendering usually takes a long time. The time it takes to render an image depends on the quality of rendering. There are a couple of different qualities of rendering. So actually using this wireframe, we can manipulate the colors, we can manipulate the other aspects of the images or data or information as per our choice, as per our slots, or as per our position of the objects. And point is that we can remove the unwanted parts, or like here you can see we can use hidden line removal process. So because some parts might not be seen or might not be visible due to the angle of the object, so we can remove that, or we can keep some part which is required to color or give some light or give some other shape or size, like that, and we can create, or we can hide other parts, so like that. So using wireframe, actually we can do lots of things, and it helps us to go through the objects part by part. That is the main point. And also here you can see that rendering usually takes a long time. The time takes to render an image depends on the quality of rendering. So if you suppose this wireframe, if you create lots of numbers of polygons, or minimal number of polygons, then that depend upon that minimal number or maximum number, that rendering process will take lots of time. So, or if your wireframe has less number of polygons, then it will take less number of time or less amount of time, or it will also affect the quality of rendering. So there are various informations, or there are a couple of different qualities of rendering. Like one is flat shading. Flat shading is that the quickest rendering method. This is the quickest rendering method. Some programs are able to render flat shaded objects in real time. So we can create that the flat shaded or solids. This is actually solid creation. If you use Blender also, we can create this type of thing, which is flat shading. So here you can see that original wire mesh has been given a shape using a flat shading over the surface of the object. So some programs are able to render flat shaded objects in real time. So we can do this in real time. So when rendered using flat shading, the computer creates an average color for an object. So it will create an average color of an object, then render each face with different amounts of black or white added to simulate shading. So objects look flat and unrealistic. No textures are applied in this mode. So here no textures are applied basically. but only that amount of mixture of black and white color is added to simulate the shading, nothing but than that. And also there is another method, that is gold, or that is gold rendering takes flat rendering to one step further, means it smooths the messy, or you can see here is that the edges of the meshes can be visible, but here you can see those things are smoothened out. So here that is the one step further from the flat rendering. It is gold rendering takes flat rendering one step further. The computer figures out values of a color on vertices of a face. Vertices of a face means vertices of these masses or polygons. Then vertices of a face, and then applies a gradient to the face. So it will gradually decrease or increase the color, and in that way it will smoothly color the all, or smoothly shade the object. This mode is not much slower than flat shading and can also be rendered in real time on some of the more powerful computers. There is another one, that is Phong. Phong is also used in various software, like Phong rendering takes rendering yet one more step further. It actually probes every pixel in visible area and tries to determine a correct color for it. It takes into account all lights and texture. This is often as good as many low-end programs render. The results are pretty good, and the time that it takes to render is not extremely long. So Phong is far more better than other two, but it takes some amount of more time than other two, but not extremely long. There is another point, is that ray tracing. So ray tracing actually is associated with the light. So the base rendering quality, it also takes very long, but the results are awesome. Everything is rendered, including shadows, lighting, reflections and transparencies. It also does another thing that other rendering options don't. It gives light a physical attribute. So you can see this is actually, this type of rendering is actually associated with the light. So for example, a rendering of pencil in a glass of water would give you the same direction effect that nature does. The pencil will appear broken. When a computer ray traces an image, it simulates a beam of light going out of every pixel on the screen. It reflects and deflects the beam of light in a similar fashion as nature would. So finally it takes outcome of all these and puts it on the screen. So here is a thing. So you can use this type of things in some software, but actually you can understand that why this ray tracing will take more time, or it will create better quality, because it give emphasis on the light also and other attributes of lights like shadows, lighting, reflections and transparencies, which are not included in the previous ones, and that is why it takes much more time than other three, but also it provides better quality. Like here the example has been shown to you, like if you immerse a pencil in a glass of water, as we know that in nature we can see that the pencil might have been broken or bended because of the immersion in the water and the deflection of the light or the visible portion, and that can be also created using that ray tracing method, which might not be able to, or might not be that much perfect in previous three. So you can understand why this will take more time or than other three. There is another one, is Radiosity. So there is new method of rendering that was recently developed. It's called Radiosity. It does something all other rendering methods don't do. It figures out the relationship in the scene of all objects present. For example, in a real life, if you take bright color ball and put down in a white room, the walls of the room are going to reflect a little bit of color from the wall. So more informations are coming in this type of method, like reflection of lights from other objects also will be added, so making them look a little reddish. For example, this is not possible in ray tracing since it does not bounce rays of matte objects such as walls, so which is not included in the ray tracing method, but it is included in this Radiosity method. So you can compare the above pictures to the one of the ray traced objects, although this is not a very good example. You can see not a very good example with other three, but you can understand, or you can go through the pictures or images available in the internet. You can see that this checkerboard pattern of the tribal has a slight effect. So you can see in these two there might have some effect. Okay, because here you can see some red color is visible here but not here. So that is the point it is saying. This adds the extra thing to render scenes and makes them look extremely realistic, and Radio City produces extremely good results. But unfortunately there is a trade-off, that is rendering time. Before the computer even starts rendering, it has to solve a certain Radio City model, which is the relationship of one object on all others once in a scene. So it takes lots of time. So this is the point is here. So you need to go through these things, and to understand more about these things you need to go through these other associative topics like color theory, illuminations, color and light, diffuse reflections, specular reflections, which are actually content of physics. And actually to understand the animation of this type like Radio City or other things, you need to have some knowledge about these things also. So that is the importance of animations and how everything is encompasses in this animation technique. So try to go through more about these things if you want to excel in the animation technique. So again I'll go through more of the type, like there is another one is transition. So we'll go through the topics one by one, and in next videos also, in more videos in next in incoming video onwards. So we'll try to go for more information about animations, like here you can see transition, morphing, or like fractals, like these things. There are various important aspects that need to know about animations or about these things. So if you find any problem or confusion, please let me know. And also if you want to add something more, or if you want to share something more, then also let me know. I'll try to resolve that thing over Google Meet. So till then, thank you.